Okay, good morning everyone. Today we are going to discuss about prevention of dust explosions. So, dust explosions are a significant hazard in various industrial processes where fine particles of combustible materials are suspended in the air in sufficient concentrations. So, these explosions occur when the dust comes into contact with an ignition source in a confined space. So, leading to rapid combustion and a violent release of energy. So industries such as food processing, pharmaceuticals, chemicals, woodworking and metalworking are particularly vulnerable to dust explosions. So the consequences of such events can be catastrophic, resulting in severe injuries, fatalities, equipment damage and disruption of operations. So preventing dust explosion is critical to ensuring workplace safety and operational continuity. So this involves understanding the conditions that lead to dust explosions and implementing effective control measures such as good housekeeping practices, proper ventilations, explosion venting systems, and adherence to safety standards and regulations. So we will discuss more elaborately on prevention of dust explosions today class. We'll discuss in detail. Okay, let's get started. Fine. So dust explosions occur when a fine combustible dust is suspended in air and ignited with a confined space. Right? So dust explosions are rapid combustion of fine combustible particles suspended in air, occurring when five critical elements come together in a confined space. So these explosions can lead to devastating consequences, including structural damage, injuries, and fatalities. So to effectively prevent dust explosions, it is essential to understand and interrupt one or more elements of the dust explosion pentagon. That is, we have fuel, combustible dust, finely divided solid particles capable of catching fire, example flour, dust, sawdust, metal powders. Oxygen typically present in the air and act as an oxidizer. Ignition source can be sparks, flames, hot surfaces, static electricity or mechanical friction. And dispersion of dust, the dust must be dispersed in the air forming a cloud of suspended particles. Confinement explosions usually occur in enclosed areas where pressure can build up. So preventing dust explosions requires addressing all five of these factors. Removing even one element can significantly reduce the risk. So fuel, oxygen, ignition source, dispersion of dust, confinement. Okay. So these are the five pentagon. Dust explosion pentagon. So next moving to next one, that is prevention strategies. So minimize the dust generation. So process design improvements, raw material control, right? So use enclosed systems for conveying, grinding or mixing. Use dust tight equipment joints. Okay, so minimizing the generation of combustible dust is the first and most effective strategy in preventing dust explosion. So two major approaches are process design improvements. So enclosed systems. Use enclosed systems for operations like conveying, grinding and mixing to limit dust release into the environment. And next, dust tight equipment and joints. Ensure all machinery and pipelines are sealed properly to avoid dust leaks at joints and connections. So raw material control. So reduce handling of fine or dry particles. So frequent movement or processing of dry materials increases the risk of airborne dust. So limit unnecessary handling to reduce dispersion. Pre-wet combustible powders. If the material is safe to handle in damp conditions, pre-wetting helps reduce dust clouds and the static buildup. So these strategies reduce both the fuel combustible dust and dispersion components of the dust explosion pentagon. So first one is process design improvements. Enclosed systems use enclosed system for operating like conveying, grinding, and mixing to limit dust releases into the environment. Dust tight equipment joints ensure all machinery and pipeline are sealed properly to avoid dust leaks at joints and connections. So raw material control reduces handling of fine and dry particles. Frequent movements of processing of dry materials increases risk of airborne dust. Limit unnecessary handling to reduce dispersion. And we have pre-wet combustible powders. If the material is safe to handle in damp conditions, pre-wetting helps reduce the dust clouds and static buildup. So this strategy reduces both the fuel combustible dust and dispersion components of the dust explosion pentagon. So next one we have control dust accumulation. So in control dust accumulation, so good housekeeping practices. So the uncontrolled dust buildup can create dangerous conditions, especially when combined with ignition sources and confined spaces. So effective control measures include good housekeeping practices. So routine cleaning, establish a cleaning schedule that ensures all horizontal surfaces like floors, beams, and ledges are regularly cleaned. Industrial vacuum systems use explosion-proof vacuum systems instead of sweeping of compressed air, which can disperse dust into the air and increase the explosion risk. Dust layer limits do not, that is thickness limits, according to NFPA, National Fire Protection Association. Dust layers should not exceed 1 by 32 inch, that is about the thickness of a paper clip for some materials. So evaluate based on risk. The acceptable amount of dust depends on the type of dust and its explosiveness, the surface area it covers, the likelihood of it being airborne. So keeping dust layers thin and contained is essential to preventing secondary explosions. So which are often more destructive than the initial event, right? So controlled dust accumulation, uncontrolled dust buildup can create dangerous conditions, especially when combined with the ignition sources and confined spaces. Good housekeeping practices, routine cleaning, so establish a cleaning schedule, industrial vacuum systems, use explosion-proof vacuum systems. So instead of sweeping or compressed air, which can disperse dust into the air and increase the explosion risk. Dust layer limits, thickness limits. According to NFPA, National Fire Protection Association, dust layer should not exceed 1 by 32 inch about the thickness of paper clip for some materials. Evaluate based on risk. The acceptable amount of dust depends on the type of dust and its explosiveness, the surface area it covers, the likelihood of it being airborne. Keeping dust layers thin and contained is essential to preventing secondary explosions, so which are often more destructive than the initial event, right? Initial events. So now coming to eliminate or control ignition sources. So static electricity, use bonding and grounding on all metal parts. Install static eliminators in high speed systems. And okay, we'll discuss. Even with combustible dust and air, an explosion won't occur unless an ignition source is present. So control strategies focus on preventing static electricity, sparks, and heat. So static electricity, bonding and grounding ensure all metal parts are properly bonded and grounded to dissipate static charges safely. Static eliminators, so use in high-speed machinery or conveys to neutralize the static buildup that could discharge as sparks. And hot surfaces and sparks, temperature control, monitor and regulate surface temperature of machinery to stay below ignition thresholds. So intrinsically safe equipment use devices that are designed not to release sufficient energy to ignite dust or vapors, avoid frictional heat, prevent metal on metal contact, and reduce friction in moving parts to avoid the spark generations. Electrical equipments, that is ATEX, that is explosion proof equipment, ensure all electrical devices used in dust prone areas are certified explosions proof ATEX rated or equivalent. So hard work permits strictly enforce permit systems for welding, cutting, grinding, and similar tasks that produce heat or sparks. So even with the combustible dust and air, an explosion won't occur unless an ignition source is present. So control strategies focus on preventing static electricity, sparks, and heat. Yes. So static electricity is bonding and grounding, static eliminators, hot surfaces and sparks, temperature control, intrinsically safe equipment, avoid frictional heat, an electrical equipment that is attacks explosion proof equipment ensure all electrical devices used in dust prone areas are certified explosion proof, attacks rated or equivalent. Hard work permits strictly enforce permit system for welding, cutting, grinding, and similar tasks that produce heat as similar tasks that produce heat or sparks. Okay. So next we have dust explosion venting. So explosion vents. So when preventing dust explosion venting. So when preventing fails, venting provides a vital line of defense by from a dust safely releasing pressure from a dust explosion. So explosion vents function special panels designed to burst out open at a specific pressure level, thereby releasing explosion pressure and reducing structural damage. Application commonly installed on silos, dust collectors, and dryers. So these locations are prone to dust accumulation and pressure buildup, making them prime candidates for vent installations. So ducting to safe areas why it's needed. Even though vents release pressure, they can also eject flame, heat, and debris. Solutions: vent panels must be directed to non-occupied zones using ducting, ensuring that workers are not exposed to the blast or flame front. So proper design of vent ducts ensures minimal risk to personal and surroundings. Minimal risk to personal and surroundings. So explosion vents, the functions are special panels designed to burst open at a specific pressure level, thereby releasing explosion pressure and reducing structural damage. Ducting to safe areas, why it's needed, even though vents release pressure, they also can eject flame, heat, and debris. Solution is that vent panels must be directed to non-occupied zones using ducting, ensuring that workers are not exposed to the blast or flame front. And the next slide we have explosion suppression systems. So when venting is not sufficient or feasible, explosion suppression offers a high-speed active approach to mitigate explosion before they fully develop. So detection and quenching: detection sensors continuously monitor the system for early signs of an explosion, specifically a rapid rise in pressure or the presence of a flame front. So respond within milliseconds, the system activates. So a suppression agent such as sodium bicarbonate, CO2 or other inert materials is discharged. So this agent rapidly cools the flame and displaces oxygen, stopping the explosion in its early phase. So objective is that to suppress the explosion before it propagates and causes significant structural damage or endangers lives. To suppress the explosion before it propagates and causes significant structural damage or endangers lives. So detection and quenching sensors continuously monitor the system for early signs of the explosion. So within milliseconds, the system activates. So a suppression agent such as sodium bicarbonate, CO2 or other inert material is discharged. Okay, objective is that to suppress the explosion before it propagates and causes significant structural damage or endangers lives. Endangers lives. And we have isolation techniques. So isolation techniques in explosion prevention and mitigation. Isolation techniques play a vital role in stopping and propagation of flames or pressure waves to adjacent equipment or areas. So prevent propagation. When an explosion starts in one unit, it can quickly travel through ducts, conveyors or pipelines. Spreading the danger, isolation methods are used to contain the explosion at its source. So we have chemical isolation involves a rapid release of suppressant such as CO2 or sodium bicarbonate into connecting ducts or piping. So the suppressant quenches the flame front, preventing it from spreading to interconnected systems. So often used in dust collection systems, silos or multi-stage reactors. And mechanical isolation involves the use of fast-acting valves, sliding gates or rotary feeders. So these devices quickly close off the duct or pipe as soon as explosion is detected. Prevents flame or overpressure from traveling through the network, minimizing the system-wide damage. So next coming to inerting atmospheric control. So inerting is preventive explosion control techniques that involves modifying the atmosphere within process vessel or equipment. So the air, which contains about 21% oxygen inside the equipment, is replaced or diluted with an inert such as nitrogen, carbon dioxide. This lowers the oxygen concentration sorry, to below the level required to support combustion. So this method ensures that even if a fuel and ignition sources are present, combustion cannot occur. So applications are best suited for closed systems where maintaining a controlled atmosphere is feasible. So common in pharmaceutical, chemical and food processing industries, used in milling, mixing, powder handling and storage of volatile substances. So provides continuous protection in sensitive operations, especially valuable for dust explosion prevention. Okay, these are the benefits. And training and awareness, personal training, mock drills. So personal training educates staff on dust hazards, ignition sources, cleaning methods and reporting. So a critical component of explosion prevention in industrial setting is ensure that all personnel are aware, trained and prepared to respond to hazards. So personal training programs must be regular, role specific and competency based to educate staff on dust hazards such as combustibility and accumulation risk, ignition sources including static electricity, hard surfaces, and open flames, cleaning methods, correct techniques for dust removal to avoid resuspension, reporting protocols, how to report near misses, unsafe conditions, or unusual observations, right? So, dust has objectives to educate staff on dust hazards, ignition sources, cleaning methods, reporting protocols, right? So, mock drills are simulated emergency exercises. They enhance emergency preparedness by testing the effectiveness of response plans, familiarizing staff with evacuation routes, communication systems, and safety rules, evaluating the response time and coordination of the emergency team. So, such drills should be documented, reviewed, and improved regularly to keep the facility ready for any potential explosion incident. So, training and awareness is very important to personal training where objectives are dust hazards, educate staff and educate them, okay, dust hazards, ignition sources, cleaning methods, reporting protocols. Mock drills uses emergency preparedness, so response plans, evacuation routes, communication systems, safety rules. Okay, so these drills should be documented, reviewed, and improved regularly, right? Next, coming to dust hazard analysis. So, in dust hazard analysis required by NFPA 652 and other safety codes include identification of combustible dusts. So, we must identify what are combustible dust are present. Assessment of explosion risk areas. We have to assess the explosion risk areas where explosion easily occurs. Evaluation of ignition sources. So, we have to evaluate uh, the sources which are ignited easily. And recommendation for controls and mitigations. So, based on investigations and evaluations and assessments, we have to recommend for controls and mitigation processes. So dust hazard analysis is required by NFPA 652 and other safety codes. Okay. Now coming to regulatory standards and guidelines, NFPA 652 stands on the fundamentals of combustible dust, and NFPA 654 prevention of fire and dust explosions. OSHA NEP combustible dust national emphasis program, and we have ATEX directives, that is equipment and the workspace for explosive atmospheres. Okay, so these are the regulatory standards we have for NFPA 652 and NFPA 654. So the fundamentals of combustible dust, it is prepared by the National Fire Protection Association, that provides the basic principles and requirements for identifying and managing fire, flash fire, and explosion hazards of combustible dust and particulate solids. And we have NFPA 654. So this is also prevention of fire and dust explosions from the manufacturing, processing, and handling of combustible particulate solids. Okay, and we have OSHA NEP, that is OSHA NEP. So these are the combustible dust national emphasis program, right? So national emphasis programs are temporary programs that focuses OSHA's resources on particular hazards and high hazard industries. So existing and potential new emphasis programs are evaluated using inspection data, injury and illness data. A National Institute for Occupational Safety and Health reports peer-reviewed literature analysis of inspection findings and other available information sources, right? And we have ATEX directives, equipment and workspace for explosive atmospheres. So next, coming to summary of what we have discussed so far. So prevention focus. So key methods: dust generation, use enclosed processes. So dust accumulation, housekeeping and vacuum systems we can use. Ignition sources, so grounding, hard work controls, safe equipments. Okay, confinement. So we have explosion venting, equipment isolation. Fire explosion response, we have suppression systems and employee training. So this is what we have discussed so far. So what is it? We are mainly focusing what prevention we are focusing on, and what are the key methods we are looking after to control this prevention. Okay, so this is what all about prevention of dust explosion. Okay, so if you have any doubts regarding this, you can ask me online or offline. Okay, so thank you all for listening. Thank you very much for listening to this class. We will see you next class. Thank you.